Hello and welcome to another Solana tutorial. Today we're in module 3 of part 3. Wait, no, the other way around. We're in part 3 of module 3 of the Solana development course. And we're gonna talk about state management. Yes, because last time we did some Rust basics and then dealt with input data. And today we're gonna deal with the accounts, because as you remember, the programs themselves don't store state, but state is stored inside individual accounts. And that's what we're going to be discussing today, how to do that from a program's perspective. So how we can read and write accounts, I think is what is in that lesson. But hey, let's find out. So James, what are we going to do today? We're gonna describe the process of creating a new account using a PDA. We should know what a PDA is by now, a program-derived address. And we'll once again use seeds to derive such a PDA, this time in Rust though, I guess. Once again, we'll need to find out how many lamperts we need for rent in order to allocate such an account. And then we're gonna do a CPI, a cross-program invocation, to initialize an account. And then once we have the account, we can update the data that is stored in this account. So those are the things that we're gonna do today. Let's get started with a TLDR. Because we should know this already, and I just said it, that program state is stored in accounts, not in a program itself. A PDA is derived with a program ID and a list of seeds, which also includes a bump. And then once we have those addresses, we can create accounts at those addresses and store our data there. On Solana, if you create a new account, you need to pay rent for it, and the amount of rent depends on the amount of bytes that you want to store. So you need to calculate the space and then allocate enough lamperts onto this account. At this point, you cannot create an account that doesn't have enough lamperts to be rent exempt. It used to be possible, but they changed it. Now every account needs to be rent exempt. And now they don't subtract that anymore, but you just need to have enough lamperts in there. And you still kind of call it rent, even though it's the rent for rent exemption, which is a bit confusing, but let's just call it rent. We just need those lamperts in there for rent. But it's an interesting kind of rent that we like pay once and then we can get it back once we delete the account. So it's not actually subtracted, which is cool. So essentially you can live rent free. It's like a deposit really. You deposit it, and as long as you have that deposit, you can keep the account. And once you don't need the account anymore, you get the deposit back. Creating a new account requires a CPI, yes, because only the system program can create accounts or allocate accounts. So the create account is an instruction on the system program. It says it here. I'm glad that I know it myself already without reading that. And then updating the data field on an account requires that we serialize the data into the account. Well, obviously the account again is just byte dump, right? It's just a number of bytes sequentially after each other. Like it's just a row of bytes. And if we want to store something meaningful, then we need to serialize it. Because we don't have any kind of like hash map or whatever. We can't work with keys and values. We need to actually work with the bytes. And therefore we need to properly serialize, as we learned in lesson 4 in module 1. Just putting the data after each other, and then you'll have a serialized version of your data. You need it in the form of a byte array. Just bytes after each other, yes. Yes. Cool. Overview. Solana maintains speed, efficiency, and extensibility, in part by making programs stateless, rather than having state stored on the program itself. Programs use Solana as a account model to read state and write the state to separate PDA accounts. It doesn't even need to be a PDA account, it can be any account. Important thing here is that the program must own the account such that it can write to it. But if it also needs to sign for that account, then it needs to be the PDA generated for this program. Just wanting to make that distinction here. While this is an extremely flexible model, it's also a paradigm that can be difficult to work with if it's unfamiliar. And that's why we constantly work with it and talk about it such that you get familiar with it. We start simple in this lesson. Well, great. Thank you, James. Next module. God damn it, I want to learn all of the complicated stuff already. In this lesson, we'll learn the basics of state management for a Solana program, including representing state as a Rust type. Cool. So we will probably do a struct again, creating accounts using PDAs, and serializing account data. So that's what we will do today. Program state. All Solana accounts have a data field. Yes, so remember, an account consists of a few fields like an executable flag, how many Lamberts are in that account, owner of the account. Damn it, what else was there? I think there was yet another thing. And the data is just those bytes that you can write. This makes the account as flexible as files on a computer. Oh yes. You can just create a new account, put some data in there. You can store literally anything, as long as the account has the storage space for it. Well, and with literally anything, we mean literally anything that you can put to bytes. Can't store your wedding ring in there, you can't store your soul in there, you can't store your relationship with your mother in there, but literally anything that you can put to bytes. And then you just need to remember what you stored there, because you'll find just the bytes. But just as with files in a traditional file system, they can also have different formats. And we're responsible for maintaining that format so that we can serialize and deserialize it. So that's writing and reading data from accounts. Representing state as a Rust type. So when we write Rust, when we write programs, we typically create the format, so the data type of the account essentially, with a structure, so a struct. For most use cases, a simple struct is sufficient. So for our note-taking program, if you were to store just 2 strings and an integer, we could do it like this, simple, and then that could be serialized using Borscht. Again, just as with instruction data, we need a mechanism to convert our Rust data type to a byte array, and vice versa. Yes, that's serialization and deserialization here for you. So serialization puts the data into a byte string, and then a deserialization takes that byte string and puts it back into the data that you can work with those fields. We use the Borscht crate to get access to the Borscht serialized and Borscht deserialized traits. So we've already seen the Borscht deserialized trait last time, where we just derived this deserialize such that we can take the instruction data and make this an instance of this struct automatically, because this Borscht deserialize automatically gives us default implementations for some methods of that trait. We learned all of that last time. And then serialize will probably do the exact same thing, just that it then works for the other way around, where we have a struct with those fields and we want to make byte slice from it. So once again, we just need to derive them on top of our struct. Good, moving on, creating accounts. Before we can update the data field of an account, we must first create the account. No shit, you can't store anything in a file that doesn't exist. To create an account, we need to know the space for rent. We need to have the address for this account and where we want to create it. Obviously, for that address, we need to be able to sign. So either it's an address that is on the curve, and then we need to provide the private key as a signer such that we can create that account at that address or at that public key with the private key. Or it is a PDA, so not on the curve, and then it needs to be a PDA for that specific program such that the program can sign for the account creation. Point is, you need to be able to sign, otherwise the system program won't allow you to create that account. Invoke the system program to create the account. Yeah, that's the third part then, actually letting the system program create the account. Now, part 1, space and rent. Since the amount of rent required depends on the space that we need and the account is created with the space, we already need to know before creating the account how much space we actually want to allocate. I mean, there is a thing now that you can reallocate, like change the size, but still in the beginning you need to give it the size that you want to allocate. So we already need to know the space. Like, we can't create an account and then decide, oh, my string is so long, that's how much I want to store into this account. We need to know that upfront. And yeah, rent is more like a deposit. So James did use that word as well, deposit. We can get it back when we close the account. All new accounts are now rent exempt, also said that. And in less than 2 years, all accounts will be rent exempt because either they will have topped up their rent to be rent exempt, or they will have been thrown out because the rent was all subtracted and then the account was deleted. So give us 2 years and all accounts will be rent exempt. But 99.9% of accounts are already rent exempt, I'm pretty sure, because why would you not do that? Now, if we wanted to store such a node state with 2 strings and an ID, then we calculate the size by simply adding up the size of the individual fields, obviously, right? So if you store 3 things, then it's the sum of the 3 things that we want to store, how much storage we need, huh? Easy. Dynamic data like strings, we also looked at this when we did the serialization, deserialization intro video. They have 4 bytes at the beginning to store the length of the particular field. So the title and the body, which are both strings, will have 4 bytes for the length plus the actual length in bytes as a total storage requirement. And then a 64-bit integer, well, obviously it's just the 64 bits, which is 8 bytes. And if we add up those numbers, then we get a number of bytes in the count length, and that we can put into a minimum balance method from the rent module in the Solana program create. Yeah, program create module. Kind of looks like a singleton to me or whatever, or maybe also a factory pattern, who knows. In any way, you get one instance of this thing and then you can work with it and say, give me the minimum balance required for this length. That does the same thing as Solana rent does in the CLI. So if I were to say, give me the rent of 0 bytes, then it tells me I need to have at least 0.00089 sol on my account. And 0 bytes, so that's just for the headers. Remember, an account also stores if it's executable, how many Lamberts there are, and the owner. So even if the data is 0, we still need to pay rent. So you cannot send less than this to a new account. It will just tell you, well, that's not rent exempt. So if I were to send 0.0005 sol to someone who does not have any sol yet, then this transaction will fail, which is interesting. That's also one problem that I had when I set up my burner program and I allowed for donations, like just a very small percentage of what they got back they should send to me. But in the beginning, that wouldn't work if there's not enough sol there, because you can't send less than that. So yeah, anyway, what I'm saying is this is a real issue that you can run into. That's why I'm explaining it to you. Anyway, so if we were to now store 1 byte, then we need to pay a little more, but who only wants to store 1 byte, right? Usually you want to store more. To make an estimated guess, if I wanted this to double, now I would just want to prove to myself that I'm smart. We had the executable, which is a bool, which is 1 byte. We had the owner, which is a public key, which is 32 bytes. And then what else is stored in an account? The Lamberts, which is probably a U64, which is 8 bytes. So that's 8 plus 32 plus 1 is 41 bytes. So if I have 41 bytes, then I would expect to have double the minimum rent. Not even close. That's probably more stored here than... I'm not smart. Probably more stored than just those 3 things. Anyway, whatever. I don't run a validator. I have never looked at the validator code. I don't know what an actual account looks like. But coming back to just us wanting to store data, right? If we wanted to store 41 bytes of data, then we would need this amount of rent on the account. So this amount of Lamberts, well, no, I think a few more zeros. But we don't need to know that by heart because we can just call methods that calculate this for us. As we did in the front end, like in TypeScript, there are also those methods there are also those functions that let us calculate the rent that we require. Yeah, moving on to PDAs. Before creating an account, we also need to have the address to assign the account. For program-owned accounts, this will be a program-derived address. Not strictly speaking, again, it can also be a program-owned account that is not a PDA, but they usually are. And we find those PDAs using find program address, as we did in TypeScript again, because it's always the same, just now we're on Rust. And this find program address will derive the PDA with the program ID and a list of seeds. I'm gonna say this so many times such that you get it in your head. And the find program address also does the thing with the bump already. So it adds a bump. I think he says that down here. Hold on, let me continue reading. And obviously, if we put in the same arguments to that function, we will always get the same results. So as long as the program ID and the seeds stay the same, I always get the same address. We can create any number of PDAs deterministically and always find them again, as long as we just provide the right seeds, kind of the seed 1, and if we put in the seed 1, then it will always give us the same program address. Then we can have a different seed 2, it will give us a different address, and if we put in seed 2 again, it will give us the same that we just had. And then we can also make it dependent on some input, like on an account. We can put the account public key as a seed, and then for that account we will always get the same PDA. So you can do some cool stuff with that. In addition to the seeds you provide for deriving the PDA, the function will provide one additional bump seed. So that's one byte that it adds at the end of your seeds. Oh, there's a cool hack that you can make with this. I have so many great ideas for like programs that you can hack, and I want to do that. I want to play the game of death where you have to hack smart contracts on Solana. So come join my Discord and join the Game of Death channel to find out more. I want to make you a hacker. As we discussed already some previous lessons, but this is important, so I mention it again. A PDA does not have a corresponding secret key, so there's no private key, which allows for the program to be able to sign. Only the program that owns the address. So this is now not the owner of the account, so you can theoretically create a PDA for one program that is owned by another program. Sometimes you want to do that because maybe sometimes, like for instance, a token account is also a PDA from the associated token program, but it belongs to the token program. You can theoretically just make a system program account, a wallet, an account with 0 bytes, for instance, with such a PDA, and then your program can sign for it. You could do this like, and then that could be your treasury for your program or whatever. But you might as well keep the ownership of the account as well. Then you can directly manipulate its lamperts. Otherwise, you need a system program. Point is, if it's my PDA, I can sign for it. And here James once again explains how the bump seed works. Like first it's 255, then if that is on the curve, then it's decreased to 254, and so on until we have one that is off the curve. For our node-taking app, we'll use the node creator's public key and the ID as the optional seeds to derive the PDA. So we just do find program address, which is in the pub key module. That's something that I also had to get in my head. The find program address is not something that you do on a connection. No, this is something that belongs to the public key, because what you get back is a public key. So that's a static method there. And it just takes the seeds and the program ID. And for us, we use the creator as one of the seeds and the ID as one of the seeds. And the ID was an integer. So we need to first put that as bytes to get byte slice from that number. And then both of the things we need to do as ref. Remember, ownership in Rust. That's how that works. But you can also for now just accept that we do it like that. And yeah, then we get back the PDA and the bump seed. We might want to save that or not, such that next time we can quickly find the bump to sign with, such that we don't need to call find program address again when we want to sign, because for signing we will need the bump seed. For creating that, the find program address method will do the bump seed, try out the seeds, the bumps. But then when we sign with it, we just need to provide the bump seed as the last byte in the signature seeds when you do, for instance, a CPI. We will see that here. But let's not skip ahead here too much. Once we've calculated the rent required for an account and a valid PDA to assign as an address, we're finally ready to create an account. Finally, to actually create it. And creating a new account requires a CPI. A CPI is when a program invokes an instruction on another program. So for instance, our program invokes an instruction on the system program, which is another program. To create a new account within our program, we have to invoke the create account instruction on the system program. Cross-program invocations can be done using either invoke or invoke sign. Now, what is the difference? James doesn't really explain that here. To my understanding, the difference is that with invoke signed, we provide the seeds for a signature being done with the PDA. If we just call invoke, then it's done with just private keys. So if we invoke, then we just keep the signatures that we got from the private keys when the transaction was signed. And if we invoke signed, then we additionally to the signatures from the private keys sign as our program with the given seeds. Another example. Let's say you want to send some SOL from your account to someone else, and the program should do that for you. Then we just need an invoke because you, the user wallet, has signed the transaction. So when the system program is called, the transfer on the system program is invoked, then it will find a signature for that account, the user wallet, and it will allow that transfer. If the same transfer should be done from an account that is owned by the program, so a PDA, then I need to do invoke signed because the user hasn't signed for this particular PDA because he can't. There is no private key for that. Program needs to sign, and the program needs to provide the signer seeds such that then a signature exists for this account, such that the system program, when the transfer instruction is actually executed, finds that signature and allows the transfer. Does it now make sense? I hope so. So we use the invoke signed because we have a PDA that we do need to sign for, because again, we want to create that account at that address, and for that address there's no private key. Thus, we need to provide the seeds because you need to have a signature for the system program to allow the account creation. Oh, you sign an instruction, not a transaction? Yeah, in this case, I guess you sign the instruction because you call one instruction. Yeah, and then the signature just exists for this instruction, I guess. This is done by comparing the derived PDA against all accounts passed into the instruction. If any of the accounts match the PDA, then the signer field for that account is set to true. Interesting. Since if we want to work with that PDA, we obviously need to provide it as an account. Remember, Solana needs to have all of the accounts defined before you start executing the transaction. So it needs to be part of the transaction. And if we put in the PDA, obviously it's not a signer because when we send the transaction, we can't sign with it. But then if we do this, then it goes through those list of accounts, and if it finds that PDA, then the signer field is set to true. That's interesting. So when it gets to the system program that we call here, then the system program will actually see it as signer true, that particular PDA. Cool. Learn something. A program can securely sign transactions this way, because invoke sign generates the PDA used for signing with the program ID of the program invoking the instruction. Yes, so obviously the seeds that we provide here are taken in combination with the program ID of the program itself, which is also why we had to provide the program ID here. Here we can create the PDA for any program ID, but when we sign ourselves, then obviously the program ID of the program itself is taken. So I can't sign as another program, obviously. And that's why we can guarantee if there is a signature done with those particular seeds, then it's definitely from that program, because another program can't just create a signature, even though they might have the same seeds, but they will not have the same program ID. That's why we can guarantee that this invoke signed actually can only sign for that program that the PDA belongs to. Not necessarily the account, but the PDA. Ugh, so complicated. This is the function definition from iterate an interface. It takes the instruction that we want to execute, the accounts it needs. Remember, for each instruction, we also need to provide the lists of accounts. And then here, the signer seeds, because if we do a signed invoke, then we need to provide the seeds, including the bump seed at the very end. And now this might look complicated because so many ampersand and square brackets. Essentially, you have a U8 slice, so just some bytes, but then you can provide more of them, so like a list of bytes, and then you can even have a list of that. Why do we need to make that so complicated, you ask? Well, let's say you want, as your seed, you want to provide several things like a string and then a public key and then the bump. So the bump is easy, the bump would just be this. But if we provide a string as a seed, then that's already this, right? Because a string, if we put that 2 bytes, then it's several bytes after each other. Why do we need that one more time here? Because we can compile a string down to a slice of U8s. Also a public key, we can compile it down to a slice of U8s. Then we put them into another list, or so another slice of those slices of U8. And then you could do it one more time. One more time. Just because. It might be a bit confusing if you don't want to do it one more time. You just put yet again a reference on top here and put it all as just one element, which has other elements like the most inner one, just the one bump seed. The last one of those 3, just one bump. So might be a bit confusing if you look at that, especially if you look at that for the first time. But really what we're doing here, we create one slice with just 1 byte in there, the bump seed. And then we do several of them and put them into a slice. And then we do that one more time, but we just have it once. You just need to remember that that's a 3-dimensional byte slice. That's just what it requires, okay? So if we want to actually do this, we provide the instruction by taking a system instruction, the create account, which again you find in the crate, Solana program crate. You provide the things that the create account needs, like, I should actually look that up what those are, but I would expect it's the fee payer, the owner? No, not the owner, probably fee payer. Then the actual account to create, the lamperts for rent, the size, and the program ID. I think so, but I'm not even sure. Can we find that out somehow? Create account from pub key to pub key. Okay, that's all the instruction I get. That's all the docs I get. Yeah, so from pub key, I assume is just the guy who pays the fees or who pays the rent. To pub key is the new public key that is created. In our case, the PDA, the amount of lamperts, the space, and then the owner is the last thing. So the owner is the program ID, our program ID. So we set ourselves as the owner. We have this space, this amount of rent, and that's the address for the account. And this guy is paying for it. Then we have the account infos, which is now all the accounts that this instruction works with. There we just need to, put in all of the accounts. We don't need to put in program ID because the program account is never changed. Like we don't read or write that. The only accounts that we do write to is this one because we subtract some lamperts. This one, well, because we create the account, add some lamperts and some space, which in Solana, by the way, is initialized with 0 because obviously it needs to be deterministic. So you can't have random data on different validators, right? So you need to initialize them with something. And well, what makes most sense is to initialize all the bytes with 0. So it's not like in C where if you memory allocate that you can get whatever is currently in storage. No, you get it cleaned like Kellogg. Yeah, so we provide those as accounts. Obviously also the system program, because the system program need for that system program instruction, obviously, because, we got to read the program to be able to do this. So if somebody were to change the system program in the same block, that wouldn't work, right? Can't be done at the same time. So that's the list of accounts. we need to provide that. And then the last thing that we provide is obviously the seeds, because we do it signed. And the seeds we decided on, they need to be the same as here above. So we had the creator key, so the public key of the guy who created it, and the ID. So again, we provide the same thing, ID as bytes and creator public key. And then note at the end, additionally, the bump. And with that entire thing, the signature is then created for this program. Cool, that's CPIs. Once we have the account, we can then put some data into it and read the data from it. That is done by serializing and deserializing. Yay! One more time, do some serialization. Essentially, all we want to do is update the account's data field. Because remember, there's the Lamperts, the executable flag, the owner, and the data field. And the data can write into or read from. Deserializing account data. First step to updating is to reading what's already there. I mean, if we just created the account, we know what's there, all zeros. But if we then wanted to update it, it's better to first read the state and then modify it and write it back. So first, we want to deserialize what's in the data field of the account, and therefore we deserialize it into our type that we have defined like this. You can do this by first borrowing the data field on the account. This allows you to access the data without taking ownership. Remember, ownership, the concept in Rust, we want to borrow this but not take ownership of it. That's why we here say borrow, such that when we drop the reference, we don't want the entire thing to be removed from memory. You can then use try from slice unchecked to deserialize the data field of the borrowed account using the format of the type that you created to represent the data. That gives you an instance of your Rust type, so you can easily update fields using the dot notation. So we can just try from slice unchecked into this particular thing, struct. So there we say what we want to fit that into, and then here we get the bytes from it. So here we have the byte slice, and this will make us a result which is either okay or error, and the unwrap gives us just the okay thing back. And the okay thing is this here. And I'm not entirely sure what the unchecked does. I would assume, not having read anything more about it, that this allows the data might not contain what we have in here, so it will, you know, try its best to fit the data in there, but if there's no data, then it will just leave them empty or something. This could be important in the beginning when it's all zeros and you try to read a string and then you try to read an int, then okay, it's all zero. But then there's data left at the end and it doesn't check that all of the data was consumed and it was put into here. But let's try and find out what that actually does, if I was correct. Normally, try from slice checks the length of the final slice to ensure that the deserialization uses up all of the bytes in the slice. Bam! I was right! I love it! Now that this is a potential issue with this function, any buffer greater than or equal to the expected size will properly deserialize. For example, if the user passes a buffer designed for a different type, the error won't get caught as easily. So since we have all zeros in our account at first, it reads the string as length 0 and then it doesn't read any more of the string, but there's still account length left for what we want to put in. So that's why we want to use the unchecked, because if we were to use the try from slice, oh, it just has the unchecked. It's not even in this crate. Nope, it just has try from slice unchecked. Try from slice is directly in the Borscht deserialize. This thing will fail if there are more bytes. And I think that is why last time when I was playing around with this, when I was making the buffer even just 1 byte too big, then it wouldn't properly deserialize anymore because the try from slice would fail. That's exactly this thing. This fails if there's more input data than it has consumed. The unchecked though, this will just say, okay, I didn't consume everything, but that's all right. That's the difference. Nice. Learn something. Cool. That's why it's unchecked. Because usually if I read unchecked, then I'm like, ooh, not so safe to use. But yes, safe to use if you know what it does. So that's why I wanted to find out for you and me. You're with me on that journey, so you're welcome. We are learning Rust. This is great. I love it. So we know why we do that. We know why we do that. We know why we do that. we know what that is, and we get our account data back in the format that we want. And then we can work with this. In the beginning, it will all be 0 though. There will be, string will be like 0 length. Oh yeah, and he doesn't even read that because it's 0 length and it's 0. Nobody cares about that. He already puts the actual data into this struct such that we can then serialize account data. Now, how do we do that? Now that we've updated this with the right values, we now want to save it back onto the account. And that we do with serialize. And that's a function that is directly on our struct because we did that. Because the DE is for deserialize and SER is for serialize. Okay, so the Porsche serialize trait has a function serialize and then a try from vec. It's so cool to learn this. So serialize will just take the entire thing and write it to a result of nothing. So that's not very saying much, but the result should be a byte slice. Looking at some code. Oh, that's just trait definition. But yeah, there are always U8s coming back. Yeah, so I'm pretty sure we get the U8 back. The result with U8s. A slice of U8s. Oh no, wait, it writes it directly there. Oh, so we don't get anything back. It directly writes it. Haha, because that's why we need to now borrow it mutable because we change it. Okay, move on with the reading. You need to pass in a mutable reference to the account data. Syntax here is tricky, so don't worry if you don't understand it completely. Well, can you just explain it if I don't understand it completely? I want to understand completely. That's what I'm here for. Borrowing and references are two of the toughest concepts in Rust. That is true, especially the borrowing. References I'm okay with because I did C. But anyway, let's see. What does that all do? It really looks complicated, yes, because we have two mutable references and then this thing that we borrow mutable and then do whatever on and then question mark. I guess the question mark does, if there's an error, it raises the error. The node PDA account.data, that's what we got, right? That's also what we used here. Node PDA account. That's the thing that we created and it's just passed in as another account. We'll see this down here in a second, I guess. Yep, just get that out of all our accounts. But let's not skip ahead too much. So our PDA, the data, we borrow it with writing permissions. So we borrow it mutable. So I guess that's a mutable slice. And then the slice itself is also mutable. Maybe that's what that means. So why did we have our serialize? So serialize takes a mutable writer. So the self in our case is the account data. The account data is the self because account data calls that serialize method. And then the writer, we provide a mutable writer and writer is of type this. So in our case, this thing here, I guess is a slice operator that takes the entire slice. So because we don't have any number here at the front and here at the back, I could say like from 1 to 10, right? 1.10 slices that slice. But with just 2 dots, I have the entire slice. And that gives me a new slice though. That's why it's once again mutable. The new slice and the elements in the slice are mutable and the slice itself is also mutable. Something like that. I don't fully get it and I wish James would explain that better here. I would love a detailed explanation that I can just open. Guess we'll just have to accept that I don't fully understand this now. But on a high level, we understand that we deserialize the account data onto the actual data field on the account. So this is where we write to. And we write directly back into the account. So the account data object is converted to a byte array. Yeah, that's what serialize does. And it sets it to the data property on the node PDA account. That's where we write it to. This effectively saves the updated account data to this new account. So that when this is requested again with get account info and the data field is read, then it contains our updated data. I mean, makes sense. That's how we store stuff in pure Rust. We could, of course, also write individual bytes into that data field directly without using Porsche serialize. We can just pump in our bytes as we want. But with the serialize, it's, you know, nicer because it takes care of the length and the individual bytes and stuff. You don't need to worry with that. Anyway, let's do some more basics. Iterators. Iterators. An iterator is a Rust trait that is used to give sequential access to each element in a collection. You might know that from different languages. We have iterators in all sorts of languages. C++ has their iterators, Java has their iterators. So essentially an iterator is a thing where you can call the next function and it gives you the next element. Yeah, next, 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 next. So it operates on a collection that is ordered, not sorted, but ordered. So there is a specific order. That's the first, that's the second, and so on. And then you can just say, give me the next. In Python, for instance, if you create a range, you can also get the next from the range and the next and the next and the next. And that comes in the specific order. So a Rust iterator can be created with iter. That creates an iterator object that references the given collection. And the iterator is then responsible for the logic of iterating over each item and determining when the sequence has finished. In Rust, iteration is lazy, which means if you don't do anything, then nothing happens. Once you created the iterator, you can call the next function to get the next item. So fairly simple. If we have a vector like this, we can make an iterator of that vector, which is our v1 iter then, and then we can just call next on that iterator, giving us the first item, so that will give us this, and then the next will give us the next element, so that's the second item. Fairly straightforward. I hope this is understandable. Even I get that, contrary to this and this. And now we can do the same with the Solana accounts that we are provided in the entry point. Remember, where's our entry point? Do we have an entry point here? No. Let's go to the lesson from last time then. There, at the entry point, you are provided with the accounts, so a slice of account info, and there you can create an iterator. Let's do that. So the account info, we can now create an iterator with a mutable reference to accounts. So that will work like this. Mutable, because we want mutable account info references, and we just create the accounts iter. At that point, instead of using the iterator directly, we pass it to next account info from the account info module provided by Solana crate. Okay, so there is a function that just takes the iterator and that then calls the next on the iterator and gives us the result back, plus probably does some more magic that I don't know about yet, but hey, can Google. So it will return the account info or not enough account keys. If there's none left, the iterator is done. Probably just makes that easier to handle that, because then we can just use the question mark here again. And if the error is returned, result again is either the item or a program error, and I guess not enough account keys is a program error. Yup. So we can just conveniently write it like this with a question mark. If the account is not provided, then program will fail. So in this case, we need 3 accounts to be provided in that specific order. So the node creator first, then the PDA, then the system program. All of those 3 would be passed into the program, into the accounts argument. Yes, I guess that's what we said. And the iterator is used to separate the account info. Means a mutable reference to the accounts argument. You can read more about references here. Yeah, I think we looked at that in the first part of this module. A mutable reference. That's a reference and the mutable. So does that first create a mutable reference of accounts and then the iterator? Probably, because if we just write reference of accounts, we would also first create the reference of account and call the iterator on it. And if we then just write ref mute, then it does that first and then call the iterator on it. Yeah, that makes sense. Because it's really complicated to read, because I would read it, since that is all written together and here's the space, first this and then the mutable reference of it, but no, I guess it's like that. And then iterate over mutable references of accounts. Iterate over a mutable reference of accounts. Wow, is that confusing? My head hurts. Anyway, point is, if we just do that, then we can call the next account info, next account info, next account info, and store all our accounts. In native Rust programs, you often see that at the very beginning, after your entry point, where it just gets all the accounts out and gives them proper names. So this is the first account, this is the second account, and it just gives in the iterator. You see that quite often in native programs, not in Anchor anymore, because Anchor makes it simpler. Abstracts that stuff away. But we're not at Anchor yet, we're still at Rust Native. Cool, now with all that background knowledge that we just acquired, we can do the demo. And as usual, I'll attempt to do the demo. You can follow along, and we're gonna do this movie review app again. And then at the very end, you can do that student intro program. So I leave that challenge up to you, and I will just go ahead and implement the demo. So we'll continue with where we left off last time in our Solana playground here with that movie review program where we unpacked the instruction data, but we didn't do anything with accounts yet. So I guess we're gonna do that today. Yes, let's. Cool. So get the starter code. If you wanna make sure that you have the right code, go there, but I will work with what we had last time, so I think my program works just fine. I can continue there, and the first order of business for me is then to create a struct to represent account data. Let's create a new file named state.rs. Now, this is again a great convention. All of the account state, like the definitions of what state looks like, we put it in a separate Rust file and call it state.rs, such that when somebody reads our code, they can quickly find where all of those definitions are. In this file, we will define the struct that our program uses to populate the data. And we add the serialize and deserialize traits to our struct. Let's go ahead, do this. Here we want to add a new file, state.rs. We import this, and then I don't want to always have to click. I think I'm going to do this. And then we want to create our movie account state struct, which requires the following things: is initialized, rating, description, title. Okay, so did I copy this? No. Is initialized, which is probably a bool, so a U8. Is that how you define structs in Rust? Forgot everything. Let's peek here real quick. I guess so. Rating, description, title. I think there was also a U8. That's a string. Description and title, not title and description. Now, the order of this is important though. If we write the description before the title, then the description is before the title in storage. Now, in my head, it totally makes sense to have the is initialized as the first byte and then the rating as the next byte, because then the rating is always at the second byte. And I don't want to put the rating between variable length stuff. So I never want to put something that is fixed length after something that is variable length, because it just makes the deserialization harder. I can't give a fixed offset anymore if I just want to deserialize one thing. Otherwise, I need to deserialize everything. But in my head, title would go before description. So that's how I would build my struct. And since it's my program, I can do it that way. And then we want to add the traits. So we hashtag derive. But I guess you have like square brackets around this entire thing, and you derive, gonna copy because I'm not good at typing, this and this. That should give us all the deserialize and serialize methods and the try from slice that we need later. So I guess that's that. Let's scroll down and see how we did. Yep, looks pretty much like what I have, except I didn't make it public. Let's make it public. Cool. Moving on. Updating the librs. Just not gonna look down. Let's update our librs. First, we'll bring in scope everything that we need to complete our movie review program. You can read about the details for each of those in the crate here. Could have a look at that. Essentially, we just import some stuff from Solana program. Try into we need to import. And of course, we import our state.rs such that we can then use the movie account from the state. So this is new, this is new. System program with all the rent, the sysvar, invoke signed, try from slice unchecked, which is part of Solana program Borscht, not the Borscht, so that's a different crate. I'm just gonna copy this, take all of that. It reorders them. Now it's alphabetical. Well, makes sense, such that linting essentially. Such that if some other person adds something else, we don't have a random order, but we always have the same order. Makes it much easier for version control. Fun facts on the side. Is that everything that you wanted me to do here now? I don't know where we use the convert try into. I guess I want to leave this out for now to find where we need it. So I'm not going to do that, but I do need that as well. Okay, it also puts that up there for whatever reason. Okay, whatever. Now let's iterate through those accounts in the add movie review function. Remember if we did that, if we know how to do that. So first thing, what we didn't do last time is put in the program ID and the accounts into our movie review. So let's do that. I'm actually going to copy this. So we say our add movie review now also takes the program ID and the accounts, and we just pass that in such that it can then work with those accounts. So step one, it's not deserializing accounts, it's reading accounts. We need an iterator. How was that? I want to have this in my memory, so I try to remember. Let's have a account iterator that's a mutable reference of accounts dot iter. What accounts are provided into our program? I want to check that here. Let's look at the front-end code that we had. It was in 1.5 probably, somewhere there. There, transaction instruction, player info account. Where the hell does that come from? What program was I working with here? Cannot find name program ID. Well, that's not helpful. What the hell do I have here? Oh, right. I was not working in here. I was working in the movie front end. There. So we created an instruction with the public key, the PDA, and the system program. That's what it did on front end with the user public key, or in terms of the movie app, it's the guy who writes the review is the reviewer, or should we call him user? User is always good, or signer, whatever. So that's the next account info, I think that's what it's called, and then we put in the account iterator, and then we do this funny thing with a question mark that it raises if it fails. So that's the user, then we have the PDA, and then we have the system program. Those three things we need to be able to extract from our accounts. Let's see if that even compiles. Build. By the way, you can also type build and it starts building. I learned that from Jonas, the Solana play guy. Errors. A local variable with a similar name exists. Yes, that's the whole point. You should take that and iterate over it. Can I just say accounts.iter? I mean, I think I'm gonna just peek. Cannot find value account. Oh, I just can't type probably. And it's being so nice anyway, and it tells me a local variable with similar name exists. Account. I just can't type. Okay, try again. Build. Yeah, build successful. Okay, that was my error. Wow, I just can't type. Cool. That's why I love my auto completion. I can just A and just complete, but not in Solana Playground. However, potentially soon there will be like more help here, or we just develop locally. That's probably the thing that we will go with. We get all the account infos. Did we do that right? Guess so. Next, account info and question mark. I think I did that right. Yes. Then let's derive a PDA. Within our add movie review, let's derive the PDA that we expect the user to have passed in. So the user, this guy, has done the same. Get the PDA from find program address with public key, his public key, and the buffer from movie title. Okay, so the title is put in as a seed, and then the program ID, of course, and it ignores the bump. And then it puts that as our PDA. So we want to do the same. Let's do some debug outputs, because why not? So how was it? I think it was in it's in public key. I'm gonna store my seeds, which is, I can name it here, right? A slice of U8 and then another slice of that. Right? If I have my seeds, that I need for find program address. Put the seeds in here and my program ID. Program ID I have here as a pub key. Perfect. This thing returns me a pub key and a U8 as this kind of tuple thingy. So PDA, but I already have that name. It's PDA and bump, but I already have that. Let's call this differently. No, it's not node, it's movie account. And then we can do a debug message, something like this. If I just put the PDA there and print it, I think that should work, right? PDA should be printable, formatable. Now, can I do something like this? Probably just want an equals, but I don't have an auto completion. This is so annoying. I want to check if they are the same. Do you have an equals while we're here? EQ implements equal for pub key. Ah, trade equal. That's this thing. Cool. So I can do that. Perfect. Nice. So this should actually work. We'll see. And then if it doesn't equal, maybe the actual movie account is also interesting in the debug. So, oh yeah, we first need to define the seeds. I wanted to make a point though with that thing. If we then do the seeds for signing, we could do something like that's the seeds. It's a slice of seeds plus then the bump, or actually bump I need to put in a separate thing. But then this would work, I guess, because we already have like a double here. And then now with that we have a triple. But if we want to provide the same seeds in here, I guess that's how that would work. Potentially I would even need to do this then though, but I'm not entirely sure. Let's just leave it like that and see if that will compile later. We'll save that for later. Now let's see if that builds. Nope. 6 previous errors. Oh, wow. Okay, so let expression in this position are experimental. Oh, what kind of fail to resolve use of undeclared type pub key? Oh, I wrote public key and I think it's pub key. Hold on, maybe that's the issue here. Unable to format the file? Oh, because I'm still missing the seeds. Ah, and that's why it doesn't allow the let here. Okay. I'm not even done writing this line. So my seeds, obviously, what are they? We said it's the public key of the user and then the title. So make this entire thing a slice and have the user as ref. I guess that's how you do it. And then the title, which is a string. And from the string, I think we need to do something like 2 bytes or something. And that as reference as well. Maybe. Still can't format that. Build 4 errors. Expected a slice of U8, but got an account info. Oh, right. It's an account info. This thing is still an account info. And to get from the account info to the public key, I freaking wish there was a dot and then it would show me what this thing has. It's really hard to develop without this autocomplete. So what we need to look at is this account info. Let's look in the docs then. Has a field dot key. That's the first thing. We'd take this public key of the account. Oh, there's more stuff that is stored in the account like rent epoch and stuff. So yeah, that's why the 41 was not big enough. Coming back here, key, the user key. So user dot key. If it's a field, then I should just be able to write key, right? No brackets, but 2 bytes is not in string. Rust string to U8. S bytes. 90% of programming is Googling. S bytes. My S bytes. My S bytes. You built yet? No, but the errors are getting... Whoa, what did I do? What? Just crashed. But it's all still here. Still have my S bytes. S bytes as ref. Build. 2 more errors. Mismatching types. So I'm comparing a pub key to an account info. Yes, that's the same issue as I had before. So really what I want to compare with here is the key and also here. And then it should build now. 1 more error. Mismatching types. Movie key. Oh, one is a pub key and one is a reference to a pub key. Consider dereferencing the borrow. All right, if you say so. Makes the code very readable, but it compiles. Finally, score. Still got a bunch of warnings, but let's ignore them for now. Actually, at that point, I would already like to test this thing. And in order to test this thing, we need some way to send transactions. So either we do it as we did last time by building our transaction here, or we could, while we have the code here, just use this. You think that will run? Can I deploy it? Nice. I just need my program ID in here. I save this. Movie front end, yarn start, yarn def, failed to compile. Okay, yarn install first. Since I'm on a new machine, maybe I didn't bring all the packages, or I deleted them on purpose. I mean, while that installs, might as well do it the good old manual way. By just providing the right keys here. So if I now were to say just test, if we run the test, we get an error because insufficient account keys for instruction. That's exactly what's happening here, because it gives us this not enough account keys error. If I weren't doing this, hey, how do we do comments in Rust? Also like that. If I weren't doing all of this and I would build and deploy, and then we test, then it would work, right? So this is really just this get next account info with that question mark that makes it fail. Actually, if I put the question mark away, let's check what that does. Build and deploy and test. You think I can do it that way? No. This is passing now. Look at that. Actually, let's do this here in the logs. Copy, paste. That will also give me the info that I don't need to go to Explorer. Log messages say it's invoked, it's reading accounts, and then it's adding the following movie ABC. Let's log use. I'm getting sidetracked here, but we're doing this to learn. Does account info have a... No, it doesn't. Okay, so what we get back here now is a result which either has the account info or the program error. Wait, but if I have a result, I can do unwrap. Interesting. So does that just do the exact same thing? The unwrap the same as the question mark? Program failed to complete. Probably not. Probably the wait, because now we get a program failed to complete. So it's got some other issue. Probably because that's not accessible. Hold on, let me, if we remove that. If only that deploying wouldn't take so long. Looking forward to the times where we deploy locally. No, same thing. Because this gives me an error, then I can't unwrap. We're gonna learn this now. You can unpack options by using match statements, but it's often easier with the question mark operator. Question mark will return the underlying value if x is sum, otherwise it will terminate whatever function is being executed and return none. Otherwise it will return none and terminate. And for a result, because we're working with results, results is a richer version of the option that describes possible error instead of the possible absence. So a result is essentially an option that also provides an error instead of the none. So if the option is not present, you can put in the error. Unwrap, for example, yields the element or panics. So returns the option, otherwise introducing the question mark. Sometimes we want the simplicity of unwrap without the possibility of a panic. Until now, unwrap has forced us to nest deeper and deeper. Really wanted to get the variable out. This is the purpose of the question mark. Ooh, are we understanding this already? I think here comes the difference. When we find an error, there are two actions to take. Either we panic, which we already decided to try to avoid if possible. And never mind what I said here. Or we return because an error means it cannot be handled. Question mark is almost exactly equivalent to unwrap, which returns instead of panicking on errors. So, okay. So the difference is both the unwrap and the question mark will make this fail, but in different ways. If I go unwrap, then this thing itself panics. And then here we get a program failed to complete, we just get a standard error processing instruction 0, and then program failed to complete. There's no exact definition of why it failed to complete, because we just got a raise error. It just failed in this unwrap. If I do question mark, then instead of panicking here, I return the error that comes from here. So return error with the invalid blah, blah, whatever it was. And that has the result that the program result, which is returned here now, that itself is a result again, and it can be okay or the error. So now it's the error. So it's not the sum, but it's the none for the option. and we provide the error because it's a result. It's a result that now contains the error that was in there in the result of this, in the result of next account info. And if we just do the question mark, then we return the error upwards into this result. Oh, that's so cool. I'm starting to understand this. I love it. Cool stuff. So that's the difference. And that's why we get different errors here. All right, cool. There was a detour to what this is. And my mental note that we need to find out what this question mark does from last lesson is now checked off. We found it out. It's just an unwrap that returns the error instead of raising one when we don't have a value present for this thing. Bring all of that back and properly test it. Let's build deploy again. And in our test, we now provide the proper accounts. So we want to do essentially that. My keys are that. We have the public key of ourselves. We get that from the playground wallet public key. We are a signer, but we don't need to be written to. Although, again, I would argue that I would also say that true because we pay for the account anyway when we then sign later. Now, if we are the fee payer in the transaction, it will make us writable. I had a long conversation with James about this. So anyway, I think we should be writable. Our PDA that, oh, now we need to also do this on front end, but again, I'll just copy that code. Our PDA is just from our thing to buffer. And then our title, movie title, buffer from the movie title. So let's also define our movie title, Solana tutorial. And then we need to adjust the title length. But now since we have a variable here, might as well take its length. Much cleaner again. And then we can here just provide the movie title. The program ID we also get from Playground directly. So that's cool. And then we just need to also write the right data. Let's write the right data. Cool. Save that. Public key was PDA here. Let's go. And then we test this again. Cool. And that worked. Let's have a look at that. See, it doesn't really want to let me copy this nicely. There we go. So log messages, core instruction 0, reading accounts, deriving PDA, then the derived PDA, this one. User provided the same is true. That's cool. Look at that. That's the true. So the user also provided the D9. So that's working. This thing provides me the same as this thing, which is to be expected. But it's nice. It's nice. It's nice. And then does it also say the following movie, Solana tutorial? Nice. So it changed the title as well. Perfect. Good. I mean, that's working great. Let's continue with creating the account, right? So back to our code, we derived the PDA. Now we need to calculate the space for rent first, right? That's what we also need to do. Movie account state has 3 fields. Actually, it has 4 fields if I remember correctly, because there was also the initialized. 1 byte each for rating and is initialized, and for title and description. I mean, he has 4 things here, right? He just wrote 3. It's a typo. James, there's a typo in your thing. Could do a pull request, but I'm too lazy. For title and description, we allocate 4 bytes plus the length. So classic. So essentially, let's do calculating rent and be like account size. Call it storage bytes. I don't care. And can we do that directly from this? I mean, we have the strings. We're going to use that. So we'll remove those underlines. 1 for initialized plus 1 for the rating plus 4 plus title len plus that's the title plus 4 plus description len for the description. And we don't want to return. Those are my bytes that we need. And then for bytes, I mean, at least the same variables you could let me autocomplete Playground. This is like most basic feature of an IDE ever. I'm being very picky here. I mean, it's really great that we have Playground here in the browser running. So I'm not complaining. I'm just saying. Complaining? No, I'm not grateful for this tool. I could just move to local development, but then again, I'm too lazy. And James says we do Playground, so we do Playground. Let rent be rent get. I think that was how that worked, right? And then we can say rent dot minimum balance for my storage bytes, lamperts. The required lamperts is this snake case, because Rust. Moving on, let's log it as well. Okay, let's see if that still builds, and nope, doesn't build. Method not found in result rent. Probably I also need to do something like this here. I return the error or get the actual rent element out. Let's see. Ha! I'm so smart. I like it. See, and it's good to understand this, because then you can be like, boom, I can fix this error fairly quickly. I read the error description, we have a result, and we want just the rent thing. So what do we do in error case? Well, we return it. Bam, bam. I like it. Getting a Rust Pro or something. I'm getting better with my Rust. Then let's deploy it. I'm waiting long again, so I guess we have once again a problem with the deploying. Cool thing here though is that we can just go here and create a new key pair. Just overwrite the old one. We don't care. AX. Because all our tests use the key pair from PG program ID anyway. So we don't even need to change much. Just deploy again. And then we can directly test again without having to change anything. It's great. So Solana Playground really is cool. Let's look at that. So our log messages, reading accounts, deriving PDA. That's now different. See, we have a different PDA because obviously we have a different program ID. So the PDA will also change. And then we're calculating rents for 41 bytes. 41 bytes. Interestingly, we had that earlier. I was predicting this already. And we will need 1176240 lamperts, which is exactly what we had here as well, right? 117624. Nice. I was totally predicting this. So that's the rent. So that's working well. Let's move on with the next step. Now that, see, we did exactly the same thing. Get with a question mark. God damn, I'm such a pro already. Now we create the actual account. Right. So that's where we now do the cross-program invocation with a system program to call the create account. And I don't feel like I need to know this by heart, which is all of that. Don't feel like I need to know this. Let's do a CPI on the system program. We invoke signed, create a system program instruction. System program instruction, create account. From pubkey to pubkey. It doesn't matter if I take the movie account or the PDA, should both be the same as we said here, but might as well use the movie account. From pubkey to pubkey, lamperts space owner. Required lamperts, storage bytes, and the owner is our program ID. This part that creates the instruction. Then we need to find documentation for this invoke signed, which takes the instruction. That's what we just provided, comma. Then the account infos, which is a slice of account info. So, comma, account info, which is a slice of account info. So what accounts do we need to provide? Well, the user and the movie account, which both are already account infos, right? And then we would provide the system program, which I'm pretty sure I can find somewhere. I'm stupid. I needed to give that in as an account info anyway. I have it here already. I can just use this, right? So basically almost the same thing as here. I mean, I could potentially even say accounts here because it's the same, except it has one more, the user. But providing an account that is then not actually needed is like not so bad. But it's cleaner to just use the ones that we actually use. So cool, that looks better now. Cool. And then the signer. So signer seeds. Again, we had slices of slices of slice, slice of slice of slice of U8. So, and that's where I said we use this now. So the seeds for signing is a slice of slice U8 plus another slice of U8. Let's see if I can just put that in here directly and if that would build. it does not. Oh, I really can't spell account. Where is my auto-completion? So yeah, okay, here we have one more too little. We are working with a slice of, a slice of, a slice of U8, and here we just have a slice of a U8, so we need to also make this to another slice of this. So with that, we got rid of this error. Cool. Then mismatching types. Storage bytes is a U64 and we want a U size. Ugh. You can convert a U size to U64 and panic if the converted value doesn't fit. Thank you, Rust, for providing this great explanation to what this code does. Try into nice. That will attempt to put the U64 into a U size, and then we get a result back. So either it's an okay and has some value, or the error, and then we can be like unwrap to just get the correct size or the error, or raise an error if it couldn't convert, because we have, I think, different sizes here. Per default, I guess those numbers are U64 and U size doesn't allow that big of a number. Maybe it's just a U32 or something. So build that again. Just have one more error, which is that the account info is not a reference account info. Oh, we have a reference and we want the, should I now dereference all of them first, such that you have a reference again? Is that what you want? No, that makes it much worse, and we don't want to copy anyway. Did I not call it that? This is weird. Same for the movie account, same for the system account. Move occurs because type which doesn't. So this is like, I also haven't seen it that way, so I think I'm doing this wrong. I'm just gonna see how we did that. You don't need to know everything by heart. So when we provide clone is what it does. Okay, so it clones them. I guess that will be fine. Okay, you just gotta remember that once, that you just clone that stuff here. Okay, let's clone it. And then it compiles. Amazing. Now I do want to try one more thing. I could also be like question mark here, right? No, because that would give me back... because then it's not a program error. Yes, because what this try into returns is not an error that is a program error, such that I can return it into a program result. It would be returnable into a normal result that just has any error, but like it needs a program error. So that error from the try into is not a program error. So we need to do the unwrap here to just raise whatever error and not return. Because if we raise, then we actually already panic. I mean panic. We don't raise, we panic, because we're in Rust. So many different words for the same thing. So many different languages. But it's cool. It's cool, I'm learning Rust. Cool. Let's deploy that again. Hold on, before we do that, let's do, if we get here, I guess we can now say account created. Now, thing is, we can only do this once. If we then want to do it twice, then we need a different title. But it's okay. Let's test it anyway. I think I'm quicker with the 2 buttons. I thought I would get rid of the buttons by typing, but no, typing is probably slower than clicking those buttons. Would only make sense if I can do both at the same time. There we go. Let's test it. Oh no. Cross-program invocation with unauthorized signer or writable account. So we're not doing the thing with the seeds correctly. It compiles, but we're not doing it right. We have the same PDA though, but we are not providing the seeds correctly. But it shouldn't make a difference in which depth I do those bytes, right? It should just flatten all of that, would be my assumption here. But just to check that, would it make a difference if I were to do the same thing as before? So not do this. Actually, I'm gonna copy this here again so you see what I do. So replace this with this. That's what we had here essentially, right? That's just a thing from above. So what I change now is I take the bump 1 in, so remove this here, comma, and then just have a 1 entry in here, right? So this bracket ends here, such that this all is the inner thing. Does that now make a difference? Question mark? Build. Oh, now it doesn't build anymore. expected slice found array. So we are having exact lengths. So we have one array of size 3 because we have 3 elements here, and then 1 because we have 1 here, and that's not what it wants. See, that's a bit complicated always with those slices and arrays. It's not the first time that I have this sort of an error, and it's always funny to try and fix it just to make sure. If I were to put that here, it would be the same, right? No, if I put it here, then it works. This is stupid. Okay, hold on. Which means it's just a type thing. If I don't specify that this is just a... I will just do this. Hold on. I will tell you specifically that this is a slice of a U8. And that's what it looks like. Does it build then? Then it builds. Because I'm specifically saying don't treat this as an array, but treat it as a slice. We don't want no size. Treat it as a slice. Cool. That fixes that. But is that now a difference in the actual execution? Like, can we now sign with that? Or is that still the same error as before? Ooh! Now it worked. Ho ho. So you cannot do this. Don't ask me why this didn't work, but apparently you need it in here. Oh, of course, man. Now I know, of course, because you can provide several signers. Man, how did it take so long for me to understand this? I get it now. I get it now why this is BS. Like this, it would treat the first thing as the seeds for the first PDA and then this as the seeds for the second PDA. But obviously, in this case, we only assign for one PDA. That's why. Oh, yeah, because you can sign for several PDAs at the same instruction, of course. That's why. That's why. Now I found out. It took a while. But we found out. So this is BS. We don't want that. We want it all in one in here, such that if there was a second PDA that needs the signature, then we could put the second thing in here, you know, like this. If I had like 2 movie accounts at the same time that I wanted to sign for, right? Then provide the signature for the first account and provide the signature for the second account. Damn! Wow, okay. But we found out. Yeah. Of course, you can have several signatures. All right, but that's why it explains that it works now and it didn't work before. Great, I'm learning Rust and Solana development. This is cool. Right, and it worked now, so we can look at this and see that we were reading the account, deriving the PDA, calculating rent. Then we did the CPI, and there we see the invoke and the success. So that's the log messages from the system program. The 1111111. So all ones is the system program. That stands for 0 in data. So it's base 58 for 0. And then I log again, account created. Cool. I mean, we don't see much of that actual account creation. But what we can do is look on this account. I'm pretty sure there's also something on the Solana CLI that allows me to look into accounts. Today we want to learn how to not rely on the Explorer. Program rent account. Show the contents of an account. That easy. Solana account. And then let's see. And then just the account address. Yeah, so let's get the account address. That's this. Paste the account address. So we see we have a public key with that balance because that's the amount of rent that we put there. The owner is the AX, which is my program. The program owns this account. It's not executable. Last time rent was paid, never. I would like to see the data as well now. Can I see that as well? Show additional information. Let's do this verbose. Doesn't really give me more. So it doesn't, I can't read, so I can't get account info, like I can't read the data on it, but I guess that's good enough because we will let our program read and write the data. And for now, it's all zeros anyway, I guess, because we didn't write anything yet. Anyway, so let's check how James did it. Also did it with a try and unwrap, try into and unwrap, and then the clone. Oh wait, no, we're somewhere completely different. We're in the demo. We were at create account. So James also does it with a try into it, unwrap, and then with the clone, yes. And one thing where we have those as seeds. PDA created. Cool. Then update the account data. Now we need to actually deserialize. We're ready to update the data field of our new account using the format in the movie account state. First deserialize the account from the PDA and then set the values. This really looks like a writing exercise. I am going to copy this. Doing it manually really helps because you forget stuff, and then, I mean, this I can copy. Let's try it manually. I mean, we've seen the code now, but it's okay. So let our account data be tried from slice unchecked. And this I'm gonna yet again Google, just had that, but I'm gonna do it again. Of a type T, so that will be our movie, whatever I call it. So the type that we want to try this into is movie. I imported it up there. Movie account state. So we try to make a movie account state from a slice. Then it needs the data. That should be easy enough to provide because that's inside our account now. Movie account data. See, and here I already don't know how to provide that properly. Good that I'm doing this manually. Let's just see what the compiler says if I try to build this. Comparison operators cannot be chained. Oh, it's literally trying to compare stuff here. No, I wanted this to be like a generic. Hold on. Try from slice generic. And then what am I effing up here? This goes before the round brackets, right? Maybe it just doesn't know that try from slice unchecked, but it should. Yeah. Something is going very wrong here. To specify type or const arguments. Well, but I included this. Is that what you want? Does that make it better? On this thing maybe? Also don't get why you say. Okay, I'll remove this for a second. Mismatch types. So you expected a slice and you found an RC. RC ref cell mutable U8. Yo, I have no idea. I'm gonna look it up again. Borrow and then expected found struct ref. Consider borrowing here. Yes, I will borrow this. Borrow the borrow, because that makes sense. And then, look at that. The error type annotations needed for result T. Cannot infer type for parameter. And then, and this is great, it considers specifying the type argument in function call. It suggests consider specifying the type argument in the function call, and there it shows it with the double point. That's what it meant earlier. I need the double point and then the type. So and then the type, and there I can now put my movie whatever struct, movie account state. That's how you do it. This is how we do it, and then it compiles. Sweet. Now I feel like I missed something else here. I'm gonna go here again. Oh, it does the unwrap. Yeah, okay. We would figure this out eventually because the account data now is not the account data, because I can now, if I were to say account data dot title is title, then it would break because this is still the result and not the actual movie account state, because there could still be an error. It would tell me here there is no title on result movie account state or error. So obviously what we need to do is and we cannot do the question mark here because the error, the standard IO error, is not a valid program error. This will work. No, it doesn't. Private field. Do I need to make all of those public? I'm getting more and more errors now. What? Value moved here. Borrow of moved value. Oh, that's not good. Whoa, what am I messing up here now? But wait, did James also make it public? Yeah, we'll leave it like that. It's not declared as mutable because we want this to be mutable, of course. Then if we build, we only have one more error, which is move, of course, because title has string, which does not implement the copy trait, or I'm doing something wrong. Okay, so I can't put in the title directly, but can I clone this? That would work. So I clone the string from title, but it worked. It must work differently. Maybe I'm messing up something with references because my title is just a string, and it's probably better if I were to make references here. Otherwise I need to always copy the string. That's not nice. Pretty sure James will have made references because he's a pro. Let's see. Yeah, he does title directly, and in his, was in the previous lesson, his code, the add movie review. No, it's also a string and a U8 and a string. How can he do that then? Let mute account. This is unfair. Why does it work for him and not for me? Title rating description. For my mind, if I were to have a reference here and here, then I would need to, you know, change a lot of other things as well. But then I could do the title without the clone, right? No. Try using a conversion like to string. Expected string from string reference. Okay, so let's not do that. Let's not have those as references. Let's keep them as strings. But I want to get this to work. Why can't I directly set title? Borrow of moved value. Where did I move it? Because wherever I had, oh yeah, there it tells me value borrowed here after move. Okay, so this was my problem. When I say adding the following movie, oh, is that where the error comes from? Hehe. So here I move the title. Wait, if I do that above and I build it, then it still works, right? Because here I can still work with that string because it's not going anywhere. It's just being used. But if I assign it to something else, then the title goes there and it's now there. And then if I wanted to log it back there, I could either go now account data title, because that's where the string lives now. That should work. Or if I want to use the title itself, then I can't provide it here. Then I needed to, you know, either clone it here or like, yeah, here this won't work anymore. I need the account data. We can read the data and then we can put it in here. Now I need to remember all the fields of this. Is initialized, rating, and description. Is initialized, rating, description. And is initialized, I just say true. Let's see if that also still compiles or if I did something with borrowing somewhere where I shouldn't. Expected U8, found bool. Did I? Maybe I should make this a boolean because is initialized, I just want 2 states. So it is 1 byte still, but I wanted a boolean. So better. Cool, cool, cool. Then we just need to now serialize it out as our last thing that we do. Lastly, we serialize the updated account data into the field of our PDA. Can I do that without looking at that code? Let's try. Account data now has the serialize function from the Borsche serialize. This has a serialize function and it takes writer. Right. So this is a bit confusing. I'm not sure what oh yeah, there was this super thing, not stupid, with the double and mute that I still didn't quite understand why I needed that, but the mutable reference of mutable whatever, of where did I want to write that into movie account dot data and then some weird stuff with borrow, right? Yeah, but borrow mutable. That's how I remember it vaguely. Method not found because I can't type. Serialize. And then, oh yeah, the trait write is not implemented for whatever I gave it here. Mutable reference on a mutable U8. That's why we borrow mutable, gives us the mutable reference, and then we need the mutable U8. Yeah, no, I'm lost. I'm gonna just look it up. And it's done with, I wasn't so far off, but it's done with this, whatever this does. So, this is so weird. It gives me the warning that it might be an error, which should be handled. Yes, that's why it does a question mark here. Then we don't have that error. We have the same warning for this thing in 76. So I guess we do another one of these. And then we have another warning that program error is unused. But didn't I specify? And then it compiles without warnings as well. Still trying to understand this part, right? If I remove this, then I have a mutable reference. This just makes it a slice, I suppose, which then has a write implementation. So essentially from this thing we make a mutable U8 slice, or maybe we just get this thing out from this entire thing. I don't know, dude. This is still something that I don't understand, but I feel like I learned a lot today, and you don't need to understand everything at the first time. So We did understand what the question mark does, so we brought that from last time to today. So mental note, I want to understand this eventually, even though I do not today. If you understand it, please tell me in the comments or in my Discord server, because I really want to know. I really want to know what this does, and maybe other people want to learn that too. But for very beginner, it's enough probably to just remember this line of code. That's how you serialize the data. But then again, for a beginner, I also recommend to use Anchor. But yeah, we're here to learn, and we are learning. So all good, all good. Now let's test if that is actually working as well. If I will now test it again, it will of course fail because it will try to create the same account that it already created. So obviously that's not gonna work. I shall demonstrate how it's not gonna work. Yeah. 0x0, the classic account already exists. Can't do that. We need to change that a little bit, and maybe, I don't know, it's dependent on the title. So Solana tutorial 2, if we were to change it with a different title, then it's a different PDA, and then it will work. And we can see that we do this CPI, create the account again, account created, edit the following movie, edit the following movie, adding the following movie, edit the following movie. Can I now, for this PDA Solana account, get the info? Yes, I needed a little bit more sol because 2 bytes more in rent, but still it doesn't show the data. So if I wanted to read that, then I need to deserialize, as we did with this thing. By the way, this thing, speaking of this thing, if I were to give you the right things, compiled client and server successfully. If I now go to localhost, I did provide it with the correct program ID, by the way, just saying. Oh no, still not. Still has a problem with the project serum anchor, just blah. See, project serum lately, you know, maybe we do not want to use that anymore. Import trace for requested module. So how about module not found? Cannot resolve. Yes. I mean, yep, no, I don't want to deal with this. So no frontend today. But it would be really nice to have that with our... What do we do next time? We do basic security and validation. Man, I would really like to end it with being able to use the movie. Let's see if with a clean installation from this. Because there was Project Serum. Maybe this works. Maybe it doesn't. We will see. We go here. Aha, okay. So James's version compiles just fine. Cool. But that's also the original that, you know, remember this? So now we want to plug in our program into this. So I want to just change, oh, that's too much here. Nope. My program ID, and somewhere else there was also a program ID, right? Wait, he wrote this inside here. This script or build the custom instruction. Simply replace the program ID in movie list and form. Movie list and form. Movie list. So I'll save this. And if I refresh this here now, probably still has the, didn't change. There, fetch page, get multiple accounts info, page handed public keys from accounts, this accounts, where is it used? Data slice, and there, there, movie coordinator TS, there is the other thing. Because now we see the Solana tutorial 2, that's what's written in here. And then another empty account, that was the Solana tutorial 1, where we created the account but didn't write anything on it. So the string and title length will be 0 and the rating is also 0. And the isInitialized is also 0, but this front end still displays it. So that's cool. And I can now do stuff like, I want to be creative, but I don't manage. Because obviously we're at home and I'm recording a movie. And I give you 4 stars. I submit this review. Please connect your wallet. Ah, oh, damn it. I pay this, but it's okay because we're on definite. Transaction submitted. Then if we refresh the entire page, sure, what the hell? But whatever, let's ignore those 6 errors. We see that our home movie is also on chain. So we can serialize and deserialize data Well, actually, mainly we serialize on-chain, and here we deserialize. I guess that concludes this little program. Anything else important that James said here? You can do the challenge yourself now. You go do the challenge. For me, it's enough. So, that's that. We are finally one step closer to finishing the Solana development course and learning all about Rust and Solana development. Yes, I am definitely learning something when doing those videos. I hope that you are also learning something by watching me learn something while doing those videos. We are making progress, and that's what counts. So you can check out the older videos that I posted here on this channel, like this video, subscribe. That's my hands do what they want. And yeah, see you in the next one. Go join my Discord for more info on the game of death. And we will start playing soon, or we might have already started. And I will see you next week for more Solana tutorials.